Let us see the first question. So the question is, what are the main features introduced in Java 8? This is definitely an easy one. So let's see the features. So Lambda expressions and stream APIs mainly to push the function style coding, these are introduced. And function interfaces, basically Lambda expressions implements the function interfaces. Default and static methods in the interface are also introduced to implement the backward compatibility and to support the multiple inheritance. Optional to avoid the null pointer exceptions. And there are changes in the date and time API as well. To achieve more async and non-blocking programming, completable feature is also introduced. So these are all the main features. We'll discuss more interview questions on all these sections. Let's move to the next question. What is a stream in Java 8 and how it is different from collection? So stream basically what it does is it will help to support some aggregate operations on sequence of elements. It basically provides a functional approach to process the collection of data, and it enables operation like filtering, mapping, reducing in a declarative way. So it's more concise compared to the traditional loops. And streams are not a data structure. That's one thing you should remember because streams will not store anything. So they are just views or the pipelines of processing the data from the collection or array or any IO resource. So stream is used to process the data. It is not a data structure. It will not store anything. And it supports a lot of operations which you can apply on the data you're processing. So the key points are it supports intermediate operations, terminal operations. So streams can be sequential or parallel also. So this is about streams. So let's understand how it is different from the collection. Stream is not a data structure, so it will not store any data. So collection stores the elements. So iteration wise, collection use even for loop, for each, or iterator. So stream is basically a functional style of iteration, you can say. So collection is modifiable. You can add and remove. But in case of stream, you can't add or remove the elements once you start processing. That's another important thing you should remember. So in case of lazy evaluation, so collection anyway it is just a storage, so we can't compare. Stream supports the lazy evaluation. So unless you put the terminal condition or terminal operation, so execution will not start. So it's lazy in nature. So collection will not have anything out of the box to support parallel processing, but stream has a built-in parallel processing capabilities. So in case of collections, you can traverse any number of times. But in case of stream, it's one time you can traverse. Once the terminal condition is added, it's done. So collection is kind of an imperative style and the stream is a functional style in nature. I hope you got it. So I hope you understood what is streams and what are the difference between streams and collection. Let's move on to the next question. Let's see the next question. So what are the difference between intermediate and terminal operations in streams? So what is the difference between intermediate and terminal operations in streams? So basically, we have to understand what is intermediate operation first. So intermediate operations basically that returns new streams, which let further execution, further operations, and they are not executed immediately. So execution happens only when terminal operation is called. So like basically the usage of intermediate operation is for transformation, filtering, mapping, etc. So you can see the examples also filter, map, testing, sorted are all examples for the intermediate operation. So what is terminal operation? So terminal operation is basically that produces the result or a side effect, or it will basically terminate the stream. So all the terminal operations are executed when terminal operation is called. Okay, like collect, reduce, consume, for each, count. All these are examples for the terminal operation. I hope you got it. So terminal operation is when the result you will see. Before you call the terminal operation, intermediate will not start executing. So this you should remember clearly. So some of the differences as we already discussed. So intermediate operation creates new streams. Terminal is an end. So we'll get the result there. So intermediate is lazy in nature. because once you add the terminal operation only it will start the execution. So intermediate we can have a chaining. So we can have map, filter, etc. chaining. But terminal operation is once you add the terminal operation, you can't further process on that. Okay. So examples you already seen like filter, map, sorted, distinct are example for intermediate. For each collect, reduce, count as example for terminal operation. I hope it's very clear to you. Let's move on to the next question. Let's move on to the next question. So the question is what are the difference between reduce, collect and for each? So these are all the three operations which is supported as part of the streams. So reduce is basically reduce the stream to a single value using an accumulator function. So I'll repeat, reduce is used to convert the stream to a single value using an accumulator function which we specified inside the reduce. So it combines elements into one. That is either you can use sum, product, max, min, concatenation, everything. So it returns an optional value. Okay. So here you can see an example. I have these numbers, I'm streaming it and I'm reducing it to this. So basically it's kind of a summation I'm doing with reduce. So it reduces a stream to single value. Okay. Let's understand about collect. Collect is basically it collects the element into mutatable container. So it can be list, it can be set, it can be map. So it performs an aggregation using collectors. So it transforms the stream into collection or custom result. So you can see the example here. We have taken we have taken a list of strings. We are filtering strings which are length greater than 3 and we are collecting to a list. So we when you want to collect the element to mutable container, it can be list, it can be set, it can be map. You can go with collect. So for each, it's a pretty straightforward one. It's basically to perform printing operation, logging operation, and some kind of update also you can do with the for each. So it returns nothing. It consumes the stream and returns void. In case of collect, it returns a container. So example is pretty clear here. You can see name stream for each we are doing. So I'll just show you an example for reduce and collect so that you'll understand the result. Let's go to the example. So here in this example, right, we are using collectors. So collector, as I said, it is used to collect the result to a mutable container. It can be list, it can be set, it can be map. Here we are collecting into map. So it will split the string into characters like H, E, L, L, O, etc. So we are checking blank because space we don't need. After that, we are collecting each character and we are having a counter like what is the frequency of the collector. So what is the frequency of each character we are counting. So if I run right, you can see character and its count is printed. So this is an example of collect. Let's say we want to use reduce. Here you can see we are using reduce, pretty straightforward. What we are doing is we are taking these numbers, we are limiting to two. We'll take only first two numbers and we are performing a reduce operation. So let's say you want to sum all, then you can just comment this and when you run it, you will get sum for all the numbers. So that's it. Reduce is to reduce a stream into single value using some accumulation operation. I hope you got it. So at high level differences are this. Reduce is to reduce the stream into single value. Collect the stream into container collection. For each is to print, log, etc. Return types, reduce is basically single value return. It's an optional type. Collect is collection. For each is void. And use case wise, if you see for some minimum, maximum string incarnation, we can go for reduce. Collect, we know already. For each also we have an idea. Functional style, like all are function style. Only for each has some side effects, like you can perform some operation on it. So this is the difference between reduce, collect, and for each. I hope it's very clear to you. Let's move on to the next question. Let's move on to the next question. So the question is, when would you use parallel stream versus stream? So parallel stream is useful when dataset is large, when you're performing CPU intensive operations, and operations on elements are independent. So like operation of one should not influence another, and order of the result should not matter. So these are all the key things to use the parallel streams. Stream, if it is a very small data set and if it is more IO bound, and when we need strict ordering, so when we have overhead of splitting, merging, so when we have such things, stream is better. So parallel stream for large data sets, CPU intensive operations, and operations of elements are independent. Let's say operation of one element if it is not prerequisite to another one, such kind of things. So a little more detailed differences. Execution wise, stream is a sequential one. Parallel stream is basically splits the work into multiple threads using fork join pool. This you should remember clearly. So execution wise, stream is basically sequential in nature, and parallel stream basically splits the work across multiple threads using fork join. And use case wise, small data sets, parallel streams for large data sets, CPU intensive operation. Threading wise, stream uses main thread, parallel stream uses available processor threads. And performance wise, it is lower and usually faster for smaller tasks. There will be overhead in case of parallel streams, and it is faster compared to the streams for larger datasets. And streams preserves the order, parallel streams will not preserve the order. So these are all the differences. I hope you understood when to use stream, when to use parallel streams, what are the difference. Let's move on to the next question. Let's move on to the next question. So the question is, what are the difference between map and flat map? This is also one of the very important question. So maybe we'll see an example first. After that, we'll come back to this to understand the difference better. So here you can see I have taken list of strings, okay, and I'm using map operation in the beginning. So I'm taking list of strings and calculating length of the each of the word, and I'm converting that into list. So basically taking A and converting into some other format. Okay. But here in the second example, right, I have list of list. What I'm doing is I'm streaming this list of list using flatMap. So here if you see, right, output of this is a stream of list. So it will do a flat mapping. So it will generate stream of integers and that is converted to list. So basically what is happening is, so here in the case of mapping, we are converting A to R or A to B. So one format to another. In case of flat map, we are basically flattening the structure. So we had list of list. Now we are converting that into a list. So that is first example. Basically, I have two strings here with space separated. So I have hello world and Java streams here as a list of string. So what I'm doing here is I have started traversing this sentences dot stream and I'm using map. So here I'm splitting the sentence using space. So what happens? Split will generate a string array of type stream because map will output stream. So it will output stream. So stream of string of array is outputted. So here we are running for each string we got it. While printing we are using arrays to string because otherwise it will print in a class address manner. It will not be readable. So that's why we are converting the string to array string. So what happens is, so here in this example, what will happen is this hello and word is split and comma is inserted when we do this conversion and we are printing. So in one array we'll have hello comma word. In another array we'll have in another array we'll have Java comma streams. So here we are doing a flattening. So we are taking the sentence and we are splitting here with space. So output of this is basically a stream of strings. So and we are doing a to list. So which will print hello world Java streams in same list with comma separated. So here there will be two entries in a list. Here there will be only one entry in a list. Let's see the output. So first one, as I already told, right, it was taking string and getting length of all the strings. Second one, it is flattening the structure to 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this one, here you can see there are two entries. Hello world is part of one entry in a list, and Java streams is part of the second index. So in case of flatMap, what is happening is it has created hello comma word comma Java comma streams. Like this is the zeroth, first, second, and third index. So it's completely flattened the structure. So I hope you understood where you will use map and where you will use flat map. I hope you understood high level difference between them. So let's see the detailed answer. So difference between flat map and map. Map is to transform each element into exactly one element, which we saw already. Flat map is basically it is used for flattening purpose. So output of the map is stream and output of the flat map is stream of flattened elements. Use case wise, it is flat map is one to many kind of a thing, or it can do a flattening of many to one also. So in case of map, it is one to one. So flat map is mainly useful for nested collection and return type, as we discussed. Map is returning stream and flat map is returning stream of flattened structures. So I hope you understood the difference. Let's move to the next question. Let's move to the next question. So the question is, when would you use parallel stream versus stream? So parallel stream is useful when dataset is large, when you're performing CPU intensive operations, and operations on elements are independent. So like operation of one should not influence another, and order of the result should not matter. So these are all the key things to use the parallel streams. Stream, if it is a very small data set and if it is more IO bound, and when we need strict ordering, so when we have overhead of splitting, merging, so when we have such things, stream is better. So parallel stream for large data sets, CPU intensive operations, and operations of elements are independent. Let's say operation of one element if it is not prerequisite to another one, such kind of things. So a little more detailed differences. Execution wise, stream is a sequential one. Parallel stream is basically splits the work into multiple threads using fork join pool. This you should remember clearly. So execution wise, stream is basically sequential in nature, and parallel stream basically splits the work across multiple threads using fork join. And use case wise, small data sets, parallel stream is for large data sets, CPU intensive operation. Threading wise, stream uses main thread, parallel stream uses available processor threads. And performance wise, it is lower and usually faster for smaller tasks. There will be overhead in case of parallel streams, and it is faster compared to the streams for larger datasets. And streams preserves the order, parallel streams will not preserve the order. So these are all the differences. I hope you understood when to use stream, when to use parallel streams, what are the difference. Let's move on to the next question. Let's move on to the next question. So the question is, what are the advantages of Java streams? So many candidates will not give the correct answer. Let's see the answer. So it's concise and readable. Basically, it will support this declarative style of programming, and it reduces a lot of boilerplate compared to traditional loops, making code more readable and easier to understand. Okay, and it improves the performance with lazy evaluation, as we already discussed. Only if the terminal operation is attached, it will start execution. So it will not start the computation unless you add the terminal operation. So that is very much important when you are processing the larger data sets and complex pipelines. It supports even parallel processing also. As we know, Stream has parallel stream. It enables efficient utilization of the multi-core processor. which leads to significant performance improvement as well. And it supports functional style of coding with all this function interfaces like predicate, function, consumer, etc., which is more cleaner, modular, and often more testable as well. So streams operations can be chained together. Like output of one operation, you can add it to another. So a kind of chain you can create. So which helps to create reusable code, more clear code. So immutability aspect. So basically streams typically operate on a data without modifying the original resource. That is one of the important things you should remember. So streams will not modify the original collection or array. So it supports immutability. So it reduces the unintended side effects. So code is more predictable and robust in nature. So this is another advantage. This is very detailed answer. Okay, so many will not be aware of all these things. So I always strongly recommend if you say all these things which conveys to interviewer. Okay, so this person knows everything about the streams. So let's move on to next question. Let's move on to next question. So the question is what are stateless versus stateful intermediate operations in streams? I think you will not see this question in majority of the tutorials. This is one of the interesting question also. So that's why I always say like watch my video till the end so to get the complete benefit out of it. So the question which I'm covering is asked frequently in the most of the interviews and they're tricky in nature in some of the cases. So I'm giving a detailed answer as well so that you should get benefit out of it. So watch the video till then. That's first thing. Second thing is I'm sharing the link to all the interview preparation material. So you can go and check out that. So the link will be in the description. So let's see the answer for this. What are the stateless and stateful intermediate operations? So intermediate operations, you are aware, the operation which transforms or produces the another stream. Okay, they are not the terminal or the end operation. So there can be stateless and stateful. So what is this stateless and stateful? So first we understand the stateless operation. So each element is processed independent of the other. So it will not retain the state across elements. So it's just faster and scalable in nature. In case of parallel processing. So you can see map, peak, filter. These are not dependent. Like execution of one element will not be dependent on another element. So they are stateless in nature. So let's see the stateful examples. So this is stateful intermediate operation. Okay, here the execution of one element depends on the other elements. So that's why these are stored temporarily and it will impact the performance, especially in case of parallel streams. Okay, so here you can see, so here examples are distinct. So distinct means element, if you have to find distinctness, you have to compare with other elements. You should know the state of other elements. So sorted is also same thing, limit, skip, etc. So these are all examples for stateful intermediate operations. So key differences are dependency on other element. In case of stateless, it will not depend on other element execution. Stateful, it will. So stateless, no extra memory. Stateful requires an extra memory, buffer, etc. Performance-wise, stateless is faster. Stateful is slower. Examples are given here. I just want to show a simple execution of an example. After that, we'll move on to the next question. Here you can see it's a mix of stateful and stateless example. The first one, this is basically stateless in nature. The second one is a stateful in nature. So I'll just show you. And so here what is happening is you can see first one is printing 4 and 8. Second one is printing 1, 2, 3, 4, 5. So operation wise, if I have to tell, I should have added a delimiter to separate the result. I hope you can understand. So here you can see we are mapping. We are taking these elements and finding all the elements which are even in nature and multiplying that with 2 and printing the result. And here it is sorting in nature. So I can't process 5 simply without knowing other elements. So I hope you understood. But this is independent. Each element execution is independent of other. So this is the difference between stateless and stateful operations in streams. I hope it's very clear to you. Let's move on to the next question. So the question is, can we configure thread count in parallel streams? So this is one of the question I've seen majority of the candidates will tell wrong answer. They will not be aware because normally parallel stream is not used that often. Even though they have used, they will not be aware what is the underlying threads it uses. So this is one of the tricky question I would say. So answer is yes, thread count used by the Java parallel streams can be configured. Okay. So another question you can get is what is the default thread count which is used by the parallel streams also. So both of that will be answered in this question. By default, parallel stream utilizes common for join pool. So the count is equals to, you can see the available processor minus one, leaving one processor for calling thread. Okay. But you can configure this by setting this property like common parallelism system property. You can set to desired value to change this count. Okay. So this will basically used throughout the application. And second thing is you can have your own custom for join pool to have more fine-grained control. You can create your own for join pool and you can submit the parallel stream. So I hope you got it. So it is possible to configure the thread count in parallel streams. The steps are defined here. But if you want to use the default one, that is basically its total number of available processor minus one. So I hope you got it. This is one of the tricky question, an important question also. Let's move on to the next question. Let's see the next question. So the question is, how does short circuiting works in streams? This is an interesting concept actually. Short circuiting means you don't need to execute the complete collection. So if the condition matches, you will short circuit there only. That's what a short circuiting operation means. So you can see stream pipeline can be terminated early without processing all the elements once the result is determined. So it works well due to lazy evaluation of intermediate operations. And it's like AND and OR operation, which is used in our coding. So types of short circuiting we have to understand. One is short circuiting intermediate operation. So here you can see we are limiting. So I just need only two elements. So after that I'll not process it. So I want to skip some elements. So I want to skip first n elements. Only I have to process the remaining ones. So something like that. So you have to basically short circuit. You will not execute all the things. So in case of terminal operations also you can short circuit. So you can use any match, all match, none match, find first, find any, all these things. So as soon as the result matches, the execution stops. So why short circuiting matters? This is one of the important things. Because of the performance optimization, you don't need to process unnecessary. So you can just imagine you are processing a large data set. So if you don't have short circuit, what happens is you have to execute all the elements. So it is memory efficient also in case of short circuit. You don't need a lot of memory to store the details. So it's very useful in case of, for example, infinite streams or a large data streams. So I hope you understood. I'll just show you a simple example and we'll move on to the next question. So here I have taken two examples. So here this is an example for the intermediate short circuiting. So this is a terminal operation short circuiting. So I'll just run first. So first one you can see what we are doing is we are just printing the first three numbers. After that we are short circuiting. So second operation we just have to find is there any even number in a given stream of elements. If it is there, we just have to short circuit. So we don't need to process all the numbers. I hope you understood. So that is the difference here. So here we have only one even number, but let's say there are more even numbers. You don't need to consider all. As soon as you match one even number, you can short circuit. So I hope you understood the difference. It will provide better performance and memory optimization. I hope you got it. Let's move to the next question. Let's move to the next question. The question is, can you modify a collection while iterating through a stream? So, can you modify a collection while iterating through a stream? So, the thing is, recommendation is you should not modify because streams are designed for transformation, not for the mutation operation. So especially if you want to add or remove an element to the original source, right, that is not recommended. It can lead to concurrent modification exception or any other unexpected behavior. So it's not recommended to try that as well. So because most of the collections uses fail fast iterators, even stream will also use that. So if some structural changes happens to a collection, then it will lead to concurrent modification exception. So the answer is, can you modify means no, you should not do it. It's not recommended because you may end up with some unexpected behavior. I hope it's very clear to you. Let's move on to the next question. Let us move on to the next question. Can Stream APIs improve performance? Why or why not? So yes, but not always. This is the best answer actually you can give. Because Stream APIs will not always improve the performance. This you should have a proper clarity. Because many of the people think that if they use Stream means it is faster. So primary goal of Stream is like readability, declarative programming. Speed is like not the first priority. Okay. Performance improvement, it completely depends on the data set size, operation type you're performing, and the parallelization. Three aspects are important in that. So when streams can improve the performance, let's understand. So parallelism, like streams make it trivial to split the workload across multiple CPU cores. Let's say if you use parallel streams, it will split the work into multiple streams and run using multiple cores of the CPU, which will basically faster in nature. So it is lazy evaluation in nature. So basically, once you add the terminal operation, then only the intermediate operations will be executed. So it will avoid the unnecessary computations. Okay. So when streams might be slower. So if you're playing with a small collection, so there it's like overhead of creating streams, lambdas, pipeline management is higher compared to the simple loops. Sometimes like too many intermediate operations can become overhead also. So parallelism misuse. So dot parallel streams can hurt performance if dataset is small. Operations are IO bound. If it is IO bound, even if you use parallel stream also, what is the problem is threads can't execute. It has to wait for the IO to respond. Only if it is CPU bound operation, parallel streams are faster. So task is not easily parallelizable sometimes. In those cases, parallel streams will also be not useful. So I hope you got it. Let's see an example also. So as I always say in my videos, I'll try to give more practical experiences so that it will register in your mind. It will be useful for your day-to-day coding as well. So let's see the example. So here what I've done is I've created a list with 100 million integers. So we are basically performing the addition operation using three different ways. One is using sequential stream. You can see I've taken the list, I'm streaming it, and I'm performing a sum operation. Same thing I'm doing with parallel streams. And the last option I'm doing with a simple for each loop. So every number I'm taking, I'm summing. So in each of these process, I'm calculating the total time it is taking in nanoseconds. Okay. So let me run it. So it will take a few seconds definitely. So you can see the parallel stream took less time compared to rest of the two flows. Even here actually for loop did better job compared to sequential stream. So maybe I'll just run it and show you one more time. So as I was telling, so parallel streams are better when you're performing operation on larger data set and it should be parallelizable. So, and it should be kind of a stateless. If there is a stateful operation, then it is not efficient. So I hope you understood. Streams are not always performant. Let's say if I change this number to, for example, 1000 or 100 maybe, and I'll just run it. So here you can see for loop did a better job. Parallel stream did a worse job. Sequential stream did a little better job compared to parallel stream. So as I already told, streams not always be performant. This you should be very clear, because many of the people who are using the streams for long also they will not be aware of this. So that's why, as I always say, I'll go to the depth so that you can understand better. So I always recommend watch my videos till then so that you will get more benefit out of it. And if you are preparing for Java 8 coding questions, I have a separate playlist as well. So I'm sharing that link. Please go and check it out. It has an exhaustive list of Java streams coding questions. So if you solve that, you can crack any Java 8 stream related questions efficiently. I'm sharing a link in the description, and I'll show you the link at the top as well. So please go and check it out if you want to prepare on the Java streams coding questions. Let's move to the next question. Let's see the next question. Can we throw checked exceptions inside the stream operations or stream pipelines? Even though some of you might have worked on streams for longer duration, then also you may think twice. Is it possible or not? So let's see the answer. So you can't directly throw the checked exception from the stream pipeline. It is not possible. It will give you compile time error, because stream operations are designed to work with unchecked exceptions or runtime exceptions. So checked exceptions require explicit handling, which does not fit neatly into the function interfaces. So that's why it is not recommended to throw. If you throw a checked exception, you will get a compile time error. So what is a workaround? So one way is you can use some helper method to wrap that exception, or you can basically use runtime exceptions, and in that you can pass the compile time exception object. So I'll show you the example in a while, but we can go through the key points. Checked exceptions are not allowed inside the stream lambda directly. So we should catch and wrap them as an unchecked exception if you want to throw, or custom function interface to handle the checked exception elegantly. So let us see the example to understand it better. So here, right, if you see, we are processing a file, and when we get an exception, this IO exception is a checked exception. But let's say I want to throw this exception. So let's say if I just remove this and try to throw, right? It is not possible. It will say again add a try catch to handle this. So let's say your requirement is to throw this exception somehow. Then one of the option is use the runtime exception and pass this compile time exception or checked exception object. This is one way to do it. So this is another way to handle it. So what we are doing here is, so we are processing the same files object using streams, and we are calling the map like the way we did here. But instead of having a try catch here, we basically used this wrap method. A wrap is basically taking this method as an argument. So this is nothing but a lambda. We are sending it to this wrap method. And here we are basically capturing that exception and throwing the runtime exception. So it's the same as previous example, but little more modular and easier to read. So same operation we are performing, but we are calling this wrap method and doing it. Another thing is, since it's a functional interface, so we have to use like throws exception here to handle that. Otherwise, we'll get an error. So simple answer is you can't throw the checked exception. So you have to wrap that checked exception object inside the unchecked exception and throw it. So that's the only way. I hope you understood. Let's move to the next question.